Having problems?
Yes.
Yes. Oh, good. It hadn't recorded all of my nonsense before this. We are now recording. We are now live. Welcome, everybody, to our session at ICSE this morning, or this afternoon, or this evening, depending on where you are. This is Human-Computer Interaction 2, and we have 6 presentations that we are having today. You can see the presenters here on the screen. We have 2 journal first papers, we have a near paper, and we have 3 technical track papers. And so we're going to jump right in and have a 5-minute presentation from each of these fine authors. And then we're going to have some great discussion afterwards. And please put your questions and comments in the chat. So to start off with, we have Arnaud from France and from University of Rennes, and he's going to present Interacto, a modern user interaction processing model. So over to you, Arnaud. Please share.
Okay, you presented my first slide, so I will switch directly to the second one. Do you hear me? Yep. Oh, I did not hear you. Is that okay? Tell me. Yes, I suppose yes. I do not listen you anymore. It's quite strange. Okay. I suppose you hear me. So you presented me. I'm Arnaud from University of Rennes in France, and we talk about Interacto. So why do we interact with computers? We interact to control a software system and underlying data. I just checked the chat. Oh, okay. Seems to be okay, to access data, and to do that we use user interaction, and the set of user interaction that has a software system form a kind of dialogue between users and the system under control. So there is a large panel of user interaction, swipe, drag and drop, click, etc., and drag lock. So currently, the current limit of programming user interaction is that the underlying model is the user interface processing model, user interface event processing model, sorry. And I will use a small example to illustrate that. So here it's a JavaScript code that defines the use of a drag lock to move an object. So a drag lock is a special kind of drag and drop. You double click, you move, you double click. And so at the first double click, you change the cursor, you register to the mouse move event, then you can move the mouse so that it moves the object. It is somehow the underlying command. And then at the second double click, you set back the cursor and you remove the mouse move listener. And that only if the primary button of the mouse is used. So in fact, in the same piece of code, you have somehow a spaghetti code that mixes several concerns, the definition of the interaction, the drag lock here, some constraints, some optimization, some feedback, etc. And moreover, this model lacks advanced features such as undo-redo, customizable undo-redo mechanism. And so we think that developers, instead of using this low-level model, should select the user interaction they want to do. Developers are not HCI designers. They should not program user interaction. They should select them, parameterize them, and then specify how the execution of a user interaction can produce an undoable command. For example, still using the previous example, I want to use the drag lock on this object. I want to produce this command. When the drag lock starts, I want to change the cursor. When it stops, I want to set back the cursor. When during the execution of the drag lock, I want to update the translation vector of the command, and that only if the primary button of the mouse is used. And this is the core goal of Interacto, is that developers do not handle user interface event anymore. They are almost invisible to developers. Instead, they focus on user interaction, command, and how to turn user interaction into command. So this is what we call an Interacto binding that are contained in a context, and the context has one undo redo history that developers can select, customize, etc. So using Interacto, this looks like this. From the context, you select your interaction, the object on which you will operate. You specify the command to produce, what to do at the beginning, what to do at the end, and what to do during the execution of the interaction. And you can define some predicate to constrain the creation of the command. So this is the Fluent API that we call an Interacto binder, and a binder is used to produce an Interacto binding. One major concept of Interacto is user interaction, so that we divided into two parts, behavior and the data, and developer only handle interaction data. This permits interaction substitution. For example, here we have the family of drag and drop, drag log, drag and drop, drag and pick, etc. But in fact, developer will only handle the underlying data, so that this enables substitution. I can replace the drag log by a drag and drop without changing my code. Okay. The second concept is the command, which is an object that contains how to execute the command and how to execute the undo redo operation. And commands are automatically saved in the current undo redo history. Some words about the Fluent API. We have multiple routines to help developers in doing some user interface jobs, such as catching errors, UI errors, throttling event, logging some usage information, etc. That's it. Thank you for your attention. Do not forget the full video.
Great. Thank you very much, Arnaud. And there is a great video online. And you can also post questions that he could answer in the chat. So next up, we have Ahmed Abdel Talif from Concordia talking about a comparison of natural language processing models for chatbots. Over to you, Ahmed, if you can share.
Thank you. Can you see my screen?
Not yet.
Now?
Yes.
Yeah. Okay, so you set the timer. Okay. Hello, everyone. My name is Ahmed Abdel Latif, a postdoc at Concordia University, and today I will be presenting our work, a language understanding platforms for chatbots in software engineering, which was published in Transaction on Software Engineering Journal, TSE, last summer. This work was done with my colleagues Khaled Badran and Diego Costa under supervision of Dr. Imad Shihab. Chatbots are one type of software bots that automate tedious tasks and able to communicate with users through natural language. Recently, many chatbots have been developed to help software practitioners in performing different tasks, such as answering questions related to the software repositories, managing the development tasks, and help the developers to maintain their microservices through natural language. And at the heart of every chatbot, a natural language understanding component, or called NLU. This component is responsible for interpreting the user message by extracting structured information from unstructured user's input. More specifically, when a user inputs a message, this component extracts the intent behind the question and the entities which present an important piece of with a confidence score that shows how trustworthy the classification is. Developing an NLU from scratch is very difficult because it requires AI and NLP expertise. So developers typically use an off-the-shelf NLU components, such as those developed by Google and Microsoft in their chatbot implementation. However, selecting the most suitable NLU for the domain of the chatbot is vital because it significantly impacts the user satisfaction. However, choosing NLU for software remains an open. Therefore, set out as a question: what is the best form to engineering chatbots? This question is to choose the candidate NLUs. So we selected to examine 4 NLUs, namely IBM Watson, Dialog, and Microsoft Lewis. Then tasks to evaluate the NLU's performance on. In particular, we selected that are related to 2 software engineering tasks. Exploring the project repository task, and this corpus contains a set of 400 queries with 10 different types such as file name and Jira. The other questions that developers frequently ask and answer from a QA website such as Stack Overflow. The Stack Overflow corpus has 215 queries with 5 entity types such as programming language. For the NLU evaluation, we trained the NLU on both repository and Stack Overflow corpus. And our last step in the methodology is to analyze the results of each NLU to find the best NLU platform to use for software engineering chatbot. More specifically, we followed an approach from prior work to rank the NLU's performance in different tasks, intensity classification, confidence score, and entity extraction in both repository and Stack Overflow to obtain an average overall rank. So, for example, IBM Watson in the repository task achieved the best performance in the intensity classification. So we ranked it here as number 1. However, it came third when extracting in the repository. We completed the average ranks in all aspects in both tasks. In this case, the NLU with the lowest average rank is the best performing NLU. The result shows that IBM Watson achieved the best NLU, followed by Rasa, Dialogflow, and Lewis. To conclude, is vital to the chatbot. Then we explained our methodology to find the best NLU for the software engineering domain. Next, we present the corpus used in our study. And finally, we presented the overall rank for the NLUs. Thanks for your listening.
Thank you so much, Ahmed. Thank you. Great summary in 5 minutes of your paper. Next, we have a near paper, and Faik Al-Rimawi from Lero Ireland is going to present this, and it's on kind computing.
Thank you very much, Peggy. Hi, everyone. I am Faik Al-Rimawi, postdoc at Lero, the SFI Research Center for Software in Ireland. And today, my collaborator, Bashar Nusaybeh, and I want to present a new idea for you, which we call kind computing. So this presentation is based on our short paper accepted at NIR, or NEAR, as Peggy mentioned, the New Ideas and Emerging Results track. So I'll start unpacking this idea by talking about kindness in the world. And among the many interesting things that one can talk about, I'll highlight 2 key things. First, that kindness is a natural human tendency. And second, it is a widespread psychosocial phenomenon which can increase happiness and well-being. Now, looking at the status of kindness in computing, we can draw 2 key points. So the first is that while digital technology has enabled kindness, like posting positive comments on social media, it has largely been explicit in doing so. Sorry, I meant implicit in doing so. And second, which explains to some extent the first, is that the presence of kindness in computing is very limited. Or in other words, computing is largely silent about kindness. And one reason for this is the lack of explicit consideration of kindness during the development and use of digital technology. So the main point of this slide is to show that there is a gap between a world in which humans have a natural tendency to be kind to each other and technology that is largely silent about kindness. So to address this gap, we propose kind computing, which is a new paradigm to incorporate kindness explicitly into the development and use of digital technologies. And it aims to increase opportunities for expressions of kindness above and beyond what current technologies offer. And applications can be envisaged in almost any domain where software mediates or can mediate humans' interactions, such as social media and healthcare. Now I want to focus on the role of software engineering. And our position here is that software engineering as a discipline can play a prominent role in enabling kind computing by building on accumulated knowledge as a starting point to create approaches that integrate kindness into software. Now, since kindness is a psychosocial phenomenon, an approach to integrating it into software will need to explicitly recognize and represent its psychological and social factors, such as emotions and social relatedness. But the main issue here is that software engineering techniques do not explicitly consider these dimensions because their current focus is on delivering digital and physical behaviors of software. And this raises two key challenges. The first is the lack of techniques to engineer kindness. Currently, there exist no formalisms nor tools that can support the explicit representation and analysis of kindness concerns in software. And the second challenge is the lack of empirical approaches to assess kindness. The point in the second challenge is not only in selecting a suitable set of empirical methods, but also in rethinking existing methods in light of the engineering challenges. And based on these challenges, we suggest a research agenda for the community, which we summarize under two headings: engineering kindness and empirical assessment. Engineering kindness aims to develop software engineering techniques that support systematic representation, reasoning, and automation of kindness in software. Now, representation requires new ways to capture elements and relationships characterizing kindness, while reasoning here requires new capabilities to analyze the nature and consequences of human actions and emotions affected by software. And for automation, it requires the development of tools to support the representation and reasoning about kindness in software, like IDEs, plugins, and so forth. Now, the empirical assessment aims to select or develop empirical methods to discover kindness requirements and evaluate it in software. This involves empirical discovery, which requires approaches to elicit kind computing requirements by exploring and applying various empirical methods. Evaluating kindness requires techniques and metrics to assess the impact of kind computing on kindness for individuals as well as for groups. And finally, implications for engineering, which requires approaches to analyze and extract insights from empirical assessment, which can feed back into and inform the engineering kindness agenda. Thank you very much.
Thank you very much. Great presentation on kindness. So now we have 3 technical paper presentations. The first one up is by Madeline Indras, and she is going to be talking about hashing it out, a survey of programmers and their cannabis usage. I don't hear you.
Yeah, forgot to unmute. Sorry about that.
Yeah, no worries.
Okay, so hello, my name is Madeline Indras, and I'm a PhD student at the University of Michigan. Today I'll be talking about our paper, Hashing It Out. And so to start, cannabis is the world's most common illicit substance. Used for many reasons, the legality of cannabis is changing rapidly. However, cannabis is illegal in many countries, including the United States and China. Okay, so why are we talking about cannabis at ICSE? Perhaps surprisingly, there's a large amount of anecdotal evidence connecting software engineering and cannabis. There are hundreds of forum and blog posts by programmers on sites such as Reddit and Quora talking about cannabis. Many posters share their experiences using cannabis while working or claim that cannabis enhances programming. Altogether, these anecdotes point to a cannabis-related subculture in software. However, many programming jobs, especially those that rely on federal funding, have and enforce anti-drug policies, such as the one on the screen from Cisco. Additionally, we find in our research that almost 30% of programmers have taken a drug test for a software-related job. The conflict between cannabis use and drug testing software jobs can even lead to hiring shortages. One such shortage occurred when the FBI had trouble finding hackers to hire because they all smoke pot and thus could not pass the required drug test. Despite this apparent conflict, surprisingly little empirical research has been conducted on cannabis use in software development. In fact, it remains unclear if, when, or why developers use cannabis while programming. As a result of this knowledge gap, tech companies cannot effectively evaluate existing anti-cannabis policies. In this talk, we start to close this gap by presenting the results from the first large-scale empirical study of software use, or cannabis use in software. To do this, we conducted a survey which we sent to developers from popular GitHub projects and to current and recent graduates at the University of Michigan. We received 803 valid responses. Over half had full-time programming-related jobs, and the most common title was software engineer. A more detailed breakdown and contextualization of our population is in our paper. So now it's time to get to the exciting bit. What did we find? Okay, to start, do programmers in our sample use cannabis while programming? So the answer here is yes. Over 1/3 of our sample have tried cannabis while programming at least once. And of those, over half do so on a regular or semi-regular basis, and 11% use cannabis while programming almost every day. This usage is very likely to be detected by a drug test. Cannabis use while programming is more common among men and developers recruited from GitHub. This last result may indicate that cannabis use is particularly prevalent in open source communities. Okay, so when do programmers choose to use cannabis? Programmers are most likely to use cannabis during personal programming projects. However, a third choose to use during work-related programming tasks. This is a likelihood that increases for remote developers. Now, to dive into a bit more detail, here are some common software engineering tasks ordered from those that developers are most likely to do while using cannabis to the least. The most common tasks are generally those that require a lot of creativity, such as brainstorming. Cannabis use is much less likely during detail-oriented tasks or tasks with an imminent deadline. This indicates that developers self-regulate their cannabis usage while programming, a finding which may call into question blanket anti-cannabis bans. Finally, now that we know when programmers use cannabis, let's explore why. Overall, we find that it's primarily for enjoyment or perceived programming enhancement. For instance, over half of programmers use cannabis to make programming tasks more enjoyable or to think of more creative programming solutions. However, not all opinions about cannabis use while programming were positive. For instance, this participant managed several programmers who fully believed that cannabis made them better, but from the outside they had various code quality issues. Now, negative opinions such as this were relatively rare. 27% of managers in our survey suspected an employee used cannabis, but less than 3% reported decreased productivity. However, these conflicting opinions motivate future observational research on the actual effects of cannabis on programming. Okay, so in conclusion, we ran the first investigation of cannabis use in software, and we found that 18% of our sample use cannabis while programming at least once a month currently, sometimes during work-related tasks. We also found that the use is primarily motivated by perceived programming enhancement, and managers rarely report witnessing negative effects. Even so, we found that 29% of our sample have taken a drug test for a programming job. Thus, our results show a conflict in the preferred practice of some developers and company policies, and our results encourage a reevaluation of anti-cannabis policies in software jobs. Finally, the intersection of cannabis use and technology remains underexplored even outside of programming contexts. As cannabis becomes more acceptable, it may interact more with socio-technical issues such as accessibility or end-user security or algorithmic bias. We hope that our work spurs more research at the intersection of technology and mind-altering substances in general. And I guess just to conclude, our materials are available on the project website, and I'm looking for research internships in 2023. So if you're interested in chatting or collaborating, definitely reach out.
Thank you so much, Madeline. Great presentation. So next up, we have testing time limits in screener questions for online surveys with programmers. And Stefan Horstman from University of Bonn is going to present this paper. You can share, Stefan. Thank you for joining us.
Yes. 1 second.
I was nudged by Bashar to say thank you.
Thanks. So I'm Stefan, and today I'm presenting the paper we did at the University of Bonn, testing time limits in screener questions for online service with programmers. This is a continuation of a paper we did last ICSI. So recruiting participants for developer studies can be difficult, especially if these participants need to have programming skills. In many cases, researchers used computer science students, for example, as a proxy, but sometimes this might be necessary that the participants have actually work experience in the field of software development. So how can research recruit these participants? We found often that they were contacted over GitHub or contacted local programming groups. And sometimes researchers also work directly with IT firms. There are also services like Qualtrics, Amazon, mTurk, and Clickworker, for example, who offer recruitment of participants, especially with participants with programming skills. So why would we test their programming skills? Their skills are often sadly only self-reported, and participants might enter the study either by accident or even to obtain the compensation, which is often offered. So if the survey or the tasks don't have any programming skills, programming tasks might be hard to detect. However, programming skill might be vital for the quality of the data. Programming skill we define very broadly as the ability to use one's knowledge effectively and readily in execution or performance of a programming task. So we already developed some screeners in the first paper, and however found that the most reliable screeners were also the ones who took the most time. So we investigate the following research question: can the effectiveness of screening questions for non-programmers be improved by inducing time constraints? And for this, we tested different time constraints with programmers and also the non-programmers. We had 3 different groups, one called base. This was actually no new time constraint. We just told them to solve the task without any additional info. Creating a baseline which we can compare the other 2 groups to, so we don't worsen the results of the developers by the time constraints. Then we had a group called No Limit, where we told the participants to solve the task as quickly as possible. We hoped that we could here minimize the time software developers would need to solve the tasks. And we had a group called Countdown, where they had a countdown rundown during the task and hoped that we could create a clear cutoff point for pass and no pass with the tasks. And this kind of worked. And so we choose the Countdown group for the in the end. So overall, we developed 22 questions. We had 16 questions for prior work and 60 new questions. The time limit for the Countdown group, we tested with 4 computer science researchers and added in bonus on the tasks the participants were allowed to spend on it. Yes, so exactly. So we tested first with the programmers, and then we also created an attack scenario where we recruited non-developer participants and gave them a bonus for each task they managed to solve correctly, to incentivize an attack scenario where participants try to break these questions. And we also told them that they are allowed to use outside sources like Google, etc. So just a quick example how these questions look like. For example, we have here a question which asks about age during programming, hoping that software developers would recognize this site Stack Overflow. However, that this site would not be known to non-programming people. We also had code comprehension tasks. For example, here's a small code which returns the word hello world but backwards, and we hope that software developers could read it and non-developers could not. So quickly going over to our results. We compare here the Countdown group of the programmers with the non-programmers because this was the same time setup. We found that most programmers can solve the task reliably and that the non-programmers often could not. We also asked the non-programmers which aids they used when trying to break the tasks. And we found that the time limit decreases the likelihood of the participants trying to solve the tasks with online sources like Google. Yeah, some recommendations for the end. Use screening questions with time limits for studies when the programming does not, when the tasks do not have any programming tasks. Most effective screeners are code comprehension questions or timed questions. And if you want to develop your own screeners, test them, because we had to discard quite a few of them because they were either not effective enough on the non-programmers or filtered out developers wrongly. Thank you for your attention. If there are any questions, you can also contact Anastasia Danilova, the main author, or just any of the authors per mail. Thanks.
Thank you so much, Stefan, and thank you for joining us. So we have, last but not least, Marielle from Wissel from Delft University of Technology to talk about bots for pull requests. Over to you, Marielle.
Thank you very much for the introduction, Peggy. So I'm Marielle Wissel, a postdoc at TU Delft, and I'm happy to present our results. We have been studying bots on pull requests and bots for pull requests for a long time now. And I'd like to show to you today the good part, the bad part, and the promising part of having these bots on pull request and how they help developers and also how they disturb developers there. So let's start with the good part of having these bots. So a bot is an interface between humans and other tools. And this interface is intended to reduce the workload of project maintainers because they automate the tasks, and the developer, the maintainer of the project, doesn't need to do that task manually anymore. And also it's intended to inform project contributors, because now we have an automation that posts comments or gives information to help those contributors to know what they need to do, what they need to improve in their contributions. But there's also a bad part of having these bots, because we found that having one bot, maybe 2, 3, and even more bots in your pull request can be seen as noise by developers, because they can overuse visual elements in their comments. There's a lot of dense information, repetitive actions, and they are sometimes time sensitive, so they give a lot of information. So to help to reduce this problem and reduce noise for developers, we have the promising part of bots. So we conducted a study, and in this study we used a technique called design fiction. And in this technique, we aimed at facilitating developers, so facilitating our participants to share and express their future thinking. And then we led them to think about the future of bots and how they wanted to have their bots in the future to reduce noise. And we introduced to them a concept of a mediator bot, and this mediator bot would help to mediate the other bots, the existing bots, and give the information that they need. So they helped us to design and define what they want to see in the future. We conduct these sessions, these design fiction sections, with 32 developers and bot researchers. And basically in this work, we asked what design strategies can potentially reduce bot noisiness. And we found, for example, that one thing that developers want to have is a separate place for bots. Because now bots cause noise because they are in the same thread, in the same flow, in the same conversation flow as humans. So they also want to see these bots in a separated place. So we prototyped this new intervention, and we have here this new tab in the pull request for bots. And it's also important for them to keep only the most recent information. So if the bots say the same thing 3 times or more, they want to see the most recent, the most important information. And they also want to summarize and prioritize what they want to look at. So if we have a list of warnings, they are going to look at it first when compared to other informations, for example. So we also summarize bot outputs here. And then also we have, they also said that they want to see the information by these bots step by step. So we also have here, we present to them this information step by step, not everything at once. And then we showed to them again this prototype and how we mapped the design strategies that they gave us to this prototype. And they also suggested other things. So for example, they want to see some timeline references for bots, because now we removed all the bots from the main conversation, but they also want to see when the bot gave that information. So there's also these important things. And what we can see from this study is that we still need to learn how to include this bot in the pull request interface and how to help developers to copy the information that these bots give. So what is next, we expect that these insights that we have here with the design fiction will turn into research directions for software engineers and also opportunities for practitioners. And if you want to collaborate or do you have any other questions, please reach out. Thank you.
Great. Thank you so much, Marielle, and thank you to all of the speakers. That was wonderful. We still have about 20 or 25 minutes for some discussion. And thank you for adding your questions. You can keep adding them, and the authors can also participate by answering them in the chat if we don't get to them today in the first part of the discussion. I'm going to start off by linking back to our first speaker. Is Arnaud still here? Maybe not. Don't see video. Yes, Arnaud is there. I was wondering, just it's a while since we heard your talk, but linking back to it and your great tool, Interacto, for user interface design, quite a novel design. I totally get it, that it helps with undo and redo, for example. That's something that a lot of us have struggled with that have done event-based user interaction. But I was wondering if you thought that the bots that you heard about in the rest of the session could be used for somehow interacting with that environment, or if your approach would be useful for designing the bot interactions. What did you think?
For writing a bot, in fact, a bot, you write some text and then you process the text, you transform as you process the text. So in Interacto, doing that is globally quite easy because it's a standard interaction. You write the text, so you have a text interaction, and then you have to define the command that process the text for doing the bot action. Maybe there is some improvement possible to integrate that more fluently, but yes. And the opposite, writing Interacto binding using a bot is quite funny. It let me think about the GitHub initiative for you write some specification in natural text and then it generates some code. It let me think something like that. Maybe something difficult with bot for writing Interacto. Interacto is we use Interacto as a Fluent API, so it's a set of related sequences. So in a bot, it may be difficult to say, okay, I want to use a drag lock, okay, then to produce this command. You need to keep the trace of what you did before. Maybe it's something more complex.
Great,
it's an interesting point.
Great, thank you, Arnaud. Thanks for jumping in on that. Marco has a question for Ahmad. I don't know, Marco, if you want to turn your mic on and ask it, or I can read it. I've actually lost sight of it.
I was asking about the user experience because you test about how good it is interpret the intentions of the tasks that are common for software engineering. But what about the user side? Do you have an opinion, or are you planning to investigate that? User satisfaction and learning curve.
Just to clarify, do you mean by user satisfaction of using the end use?
Yeah, the developers, that the engine.
Yeah, okay. Yeah, actually, this is a nice project to have for, I mean, this is a nice project to have for to investigate or explore the user satisfaction. We did not evaluate this aspect. We just focus on the accuracy and the performance of this in use in the software engineering domain. But definitely, it is a great idea for a future work. And in terms of my opinion, I think the closed source in use, IBM Watson, Microsoft LUIS, and Google Dialogflow. Personally speaking, I am more satisfied using them compared to Rasa, because they are investing heavily in the user interface to facilitate training and testing the NLUs. Also, the closed source NLUs, they are providing some examples, pre-trained examples, so they can give you an idea what are the different types of questions or people that they might ask. I hope I answered the question.
Thank you so much. Thanks for the question, Marco. Thanks for the great answer, Ahmed. I'm going to switch to Faik and ask Faik a question. If you want to turn your camera back on. Actually, there's a couple, but let's talk about this one. So Paul earlier in the thread asked about what metrics, and then Matthew asks that great subject, great idea. But he's an optimist and agrees with the idea, but do you fear engineering kindness could lead to gamification of it? Devaluing the genuine kindness. What do you think? Have you thought about this?
Okay, so interesting. I think this relates to something we actually talk about in the paper, which is the ethical dimension of integrating kindness into our software. And the idea here is that we might get into something, someone might get into something we call skill atrophy, where someone becomes dependent or too dependent on the software to perform acts of kindness or to do acts of kindness for different reasons than actually to help others. So it's a concern that we need to keep in mind when we are developing our models, techniques, or looking at the requirements. So it's definitely there, and we need to take care of it and make sure that it does not devalue the value of kindness. About the metrics, just to say, I think the simplest would be what we call the number of acts of kindness. So acts of kindness are usually the way kindness is manifested in the world. You know, you go and you say good morning to your colleague, for example. So it's an act of kindness, say. So the number of acts of kindness that one or maybe the software does could count as a metric. So this is relatively simple. Relatively simple. I mean, we still need to define what is an act of kindness and what are its components, relationships, and so forth. So it's not so simple, to be honest. But more complicated would be the impact or the effects of these acts. So you can have the quality of the acts of kindness. So maybe some of them are of higher quality or have more positive impact on a person, to maybe like posting a positive comment on someone's status. That could be one act of kindness, but actually helping someone online, donating money to them for their cause, that could be maybe having a better impact on them. Yeah.
Great. Thank you so much, Faik, for addressing that question. I'm sure lots of food for thought there in the future. Madeline, there's quite a few questions for you in the chat. Maybe you can also sort of answer some of those now or later. I'm going to see Matthew again has another question. I'm not sure if Matthew's there. If you are and you want to turn your camera or mic on and ask this, that would be great. I don't actually see a picture for you. Something's coming. Yeah, Matthew, did you want to ask your question? The one about the ethical and legal issues.
Was about the other stuff than the legal and ethical issues. So assuming you can, pass through all these paperwork, and that won't be easy. I'm still wondering, how would you even establish a reliable protocol to test this? Because the maybe naive one in mind would be to just give some cannabis to some programmers and not to others, and see how they react differently. But then there's the personal expertise, and there's even if they're used cannabis or not before, that would clearly change the results. If some aren't used to it, then the first-time users will be probably perform much worse. But if they're used to it, then the withdrawal effect might also negatively impact. So yeah, do you have any thoughts about how to actually tackle this problem past all these like ethical and legal issues?
Yeah, I think that's a really excellent question. And you're absolutely right that your level of past cannabis usage really does impact how it affects you. There's a ton of studies, I guess more on the medical side, which are looking specifically at that. So if you're a heavy user, you're going to see much less of an acute effect for the same dosage as someone who's an occasional user. But we are really interested in testing this. And so the way we're going about it, we have a study planned. We just got funding, yay, but going through some of the other, more of the ethical side that you're mentioning right now to figuring out the best way to do it for everyone. But we're going to be recruiting developers of two groups, some who are, I guess, moderate users, so maybe would use every once in a while, but have used cannabis. We can't really look at people who've never used cannabis because I don't feel comfortable asking people to use cannabis for the first time for a study. But so we'd have that one group, and then we'd have another group where they are much more habitual cannabis users, and you'd have them come in for 2 sessions, and one session they do it, I guess, sober for that time, and then the other time not, and you can compare like differences in either like coding, like bugs in code, or diversity of solutions, like metrics of code creativity, or those sorts of things. So that's currently in the works, but you're right, there's a lot of moving factors, and so you basically just need a lot of people to come in, one time high and one time sober in randomized order. So yeah.
Great, thanks, Marielle. Thanks for the question. And there's more questions. Paul Rolfe has one as well, a bit related to that, and Marco has one about bias. Maybe you can add some comments. We may come back to it. I thought I would ask a question for Stefan next.
Sure.
Yeah, so let me pick one that I asked. So I thought one of the things that I struggle with when I teach is that sometimes my students don't necessarily have the right skill, and I try to figure that out early in the term to catch that, especially in the early years. Do you think some elements from your study could be used in other settings, like educational setting? Have you thought about that?
So maybe the tasks were designed in a way that we just check for a baseline understanding of programming. We looked in related work for like measuring skill level with tasks, but mostly what we found were in the setting of company recruitment, the evaluating of potential hires, which were like half an hour programming tasks on 2-hour programming tasks and stuff like that. So this would be way too much effort, I think, for just a survey or something like that. But if you want to check if your students just have a baseline understanding of programming, maybe some of the tasks could be useful here. But if you want to check, oh, is this class full of really good programmers, or is it just intermediate programmers or beginners, then I think that's not what the tasks were designed for, sadly. But you can always try them out and see what the results are if you want.
Yeah, thanks so much. Yeah, thanks for those ideas.
Sure.
Thanks for the paper and presentation. For the next question, I'm going to pick one that has 6 votes, and I'm sorry I asked it, but I think 6 people want Marielle to answer this question. So I think we all really loved the participatory design fiction approach that we heard about today, and it shows a lot of potential, I think, beyond bots. I was curious, what kind of feedback did you get from reviewers about this approach? And did they accept it as a rigorous approach? Did they like it? Yeah, do you want to share with us?
Yeah, sure. Thank you for the question. It's a really nice question. And we did not receive any negative feedback about the approach itself. It was really interesting. I think it was one of the first papers to use design fiction in a software engineering scenario. But it's an established method, technique in the HCI field. So in the HCI field, for example, they have specific calls for design fiction studies. And so yeah, we did not receive any negative feedback. It was really, really interesting. And I do think there's a lot of potential for these kind of studies in the software engineering research.
Thank you so much, Marielle, for sharing that with us. Yeah, great approach. I noticed that Dana has a question, and she says she'll turn her camera on and ask it. Are you still there, Dana? Hopefully.
Yes, looking for the buttons. I'd like to bring us back to discussion of kind computing. And this is both for Faik and Bashar, who I know wants to talk about this. Maybe because I'm getting old or I'm exhausted, but I have sent so many thank yous in the last weeks, right? And I use emojis now. I love the love button and I feel like we need to be kind with each other because everybody's so exhausted and everybody's trying to do their job from their homes, right? And I wonder at the same time if COVID has made it even worse, Bashar. Is it a combination of age and COVID? And I know I'm rambling, and I will come to a question, but so it's and then Madeleine's study made me think about developers. So what are the users that we're targeting in this research and impact? Bashar, is it developers who we need to be kind towards? Is it the end users? We're doing now experiential learning projects in one of my programs, and I have students developing a digital platform for patients with brain injuries. And there's a lot of consideration that has to be given with how we ask questions about, what do they need from the platform? And kindness is really what's at the basis of all this, right? They are a vulnerable population that we need to be working with. So my question is, what can you say a little bit more from the scope of the work that you envision and the methods that you see happening? I acknowledge I haven't read your paper yet. It's on my list. I'm getting to all the papers I want to read. But we've been using design thinking methodologies, as in empathy-based cycles, getting to understand the real, the needs of these people and where kindness plays a big role. So I leave it there. What type of users and methods you envision? Give us a bit more.
So I'm assuming Faik is okay for me to answer it because Dana addressed me directly. So there's lots of layers to your question, Dana. I think a simple answer would be that it's everywhere. It is in software development teams, and it's also at the end users who might use software, but it's also other parties who might be affected by the fact that their friends and families might be experiencing difficulties. So the scope is very broad. It's a value in society that we care about and has a place in lots of places in our society. So how we study it depends on the context in which we're using it. So if we're studying it in terms of users, people under COVID perhaps might be lonely or might not be very mobile. And so acts of kindness could be very directed towards addressing those very specific ills in our society. So, visiting someone in their home or providing a service. So they could be very, very functional acts. And if you want to do that, you need to understand the nature of the problem, which is it's a requirements elicitation exercise in its own right. But then the interventions themselves may also be straightforward, can be functional, but they could also be something that's psychosocial. And how do you make people less lonely? And that isn't necessarily delivered by the technology, but perhaps recognized by it as opposed to intervening with it. So there's lots of layers to this, and how you study it again can be a very technical issue. You can see, as Faik said, you can count the number of acts, something, how many likes something is given, but that's rather mechanical. And not necessarily what we're probably looking for. We're trying to look for emotional well-being or emotional improvement, or perhaps material benefits, and that might require us to be explicit about those metrics. And the key for studying it in software engineering is to be actually explicit about what problem you're trying to solve, what sort of benefits you're trying to achieve, and then it becomes something that we can study using a range of methods. So I don't know if that gives you a broad direction in which I think this can go.
Yeah, definitely. You also made me think about we need to come up with measures of well-being, right? If that's the impact, one of the impacts you're looking for, right? How do you see that in real world, right?
And you mustn't overdo it. The idea that you can be overly kind can be also almost insulting to people, and so you've got to. It's something that you have to be careful with. But you have to study it in any kind of function that you introduce to an organization.
Thank you.
Great. Thank you, Dana. We have a couple of minutes left. Paul had a question also on kindness, but I don't want to end this session on a downer point. So I'm going to suggest to Paul that could you reframe, why don't you jump in? I know your camera is working today, and maybe reframe your question in a way that you could give some advice to those of us on the call that do see value in elevating kindness, and how we could do that, because I know you have vast experience on validated surveys and research from other areas. How could we take this other research and bring it into our community to account for context and culture in studying and promoting kindness. Do you have any ideas on that? Sorry to put you on the spot and ask you a question instead of letting you ask one. Are you there, Paul? Oh, maybe not. Maybe his camera's not working again. I know he had problems yesterday. Okay, well, I will just fill the last minute with an anecdote on kindness that I shared in the chat. That, you know, emojis are very important. They play quite a big role, and looking at how those could play a role, I think, across development tools is really important. So I know, Dan, I'm supposed to finish 5 minutes early, right, so that people can go. Any last comments from any of the authors? This was a great session. We had quite the range of topics, and yet there were interesting threads across all of the topics. So I was thrilled to be able to chair it. And
thank you, Peggy.
Yeah.
You've been such an awesome chair. Thank you so much.
Oh, it was a fun session. I just loved it. So thank you for putting me on this one, Dana. You matched me well. Yeah, thank you all. And go check out the papers, and there's more videos online, and meet each other, and maybe some collaborations will form. Okay.
Yeah, on kind bots.
Yes,
I
on
think next
kind
year
bots,
we
I know.
on kind bots.
That could be it.
See you later, everyone in Pittsburgh, hopefully. Bye.
Okay, take care. Bye-bye.
Bye-bye. Thank you.
Bye. Thank you.
Bye.
Thanks, everybody.
Bye.
That was a great session.
Yeah, that was fun. Really interesting.
Yeah. Okay. I guess I think I was supposed to finish it at 5 minutes 4. So.
Yeah.
I know.
It's interesting about the effect of any intervention like that, anticipatory ethics of it all. You know, anything that we introduce might end up causing problems, and I think for kindness or anything else, sort of going through that process is quite useful.
Yeah. Yeah, there's a lot of issues. Yeah, you're breaking up a little bit. You were very clear before when you spoke, but your voice is breaking up a bit. I don't know what's going on. I gave a talk on bots the other day, actually, and I hadn't read your paper at Kind Computing at the time, but I talked about using bots to increase people's well-being and happiness, and about being kind to each other. So and then I read your paper, and I'm like, oh, okay, I wasn't absolutely crazy to suggest that. I think there could be some nice work there.
Oh, is there a paper with that?
There's some slides and a video from, it was an invited talk at the BotC workshop. Yeah, and I thought, oh, this is probably kind of crazy, but whatever. That's what you do in an invited talk.
So we do software engineering for the bots, the kind bots, and then we've got a project.
Yeah. You interested?
Yeah. Coming to Limerick?
Yes, I will. Especially now that COVID's over. I shouldn't say it's over, since the restrictions are over, not as many. All right.
Okay.
I guess,
Nice to see you, Peggy.
Nice to see everybody. Thanks for joining. And there is another session starting with Mark Harmon, I think. Take care. Bye-bye.